So our goal today is to be able to write situations for graphs, be able to write our own story for it. And then the other thing we have to do is tell whether it's discrete or continuous. So let's just start with that part first. Let's look at the graph and say, because that would help us also write the story. Is it a discrete or a continuous graph? So let's call this one our graph A. Let's just call it number 1, okay? Graph A, let's just call it number 1. So first of all, is that a discrete graph or a continuous graph? Continuous. How do we know the difference? What's the difference between a discrete and a continuous graph? Get your book to help you out. Need you to engage.
Ellie or Andrea, I gave them a trick yesterday. What was that trick? And they had you guys write your notes.
How do we know whether it's discrete or continuous?
If it's discrete, it has dots, and if it's continuous, it has lines.
Yeah, if it's discrete, it has distinct points on it, which we can call dots. Or if it's continuous, then there's lines or curves, and they just keep going. They're connected to each other, aren't they? There's like a, all the dots have been connected, basically. So our first one we decided is a continuous graph, right? So let's put that this is a continuous graph because it isn't just distinct points. And then the other thing that we want to do is we want to take the time to identify what's happening. This is called the x-axis, remember, and this is called the y-axis. Let's talk about what's happening on the x-axis. What's happening on the x-axis? So in our story, this is one of the things that has to be, referred to. What's on the x-axis? What? Time. We don't know what it's measured in, we just know it's time, right? And on the y-axis, as we're talking about the time going by, we need to talk about the what? The temperature. The other thing that is helpful is if you also take the parts of the graph and give them like some words, you can identify how many pieces are there to this graph, even though it's continuous. How many pieces are there that we're going to need to describe in our story? 1, 2, 3, 4. So let's describe each of those regions. What's happening there? Okay, what's happening in that first region? It's constant, isn't it? Yeah, that's a constant. So something's going to have to stay constant as we're telling our story. Okay, how about this one? What's that doing? It's decreasing, first of all, right? And maybe we could talk about, is it decreasing quickly, slowly? Is that slowly, do you think? Look at how much space it covers over the x-axis. That's how you can tell. Look at there. It's pretty sharply, isn't it? Because it doesn't take much time for that decrease. On the x-axis, it's really not covering much time, so we would probably say it decreases sharply or quickly, at least. Okay. And then we have our region right here. What's happening in that one? Constant again. And then our last region, it's doing what?
Going up.
It's increasing. Okay, so yeah, it's going up. It increases. And then we're going to talk about maybe, that one doesn't go quite as sharply, does it? Because I look at all the time that it took, or what do you think? Is that? But could we maybe still use the word quickly or something like that? Anybody got a better word? You've been looking in the book, and maybe that'll help you out. Anybody got a better word for us to use? Okay. So now when we start, the other thing we have to take into account is, okay, where does the graph start? It starts up on the y-axis. It's over a little bit on the time. I don't know if that really matters quite as much, but so the temperature is up here. It's not down at 0, right? Okay. So anybody think they could come up with some sort of a story that would have a situation that would have something to do with, as time goes on, here's what's happening to the temperature? what about, go ahead. Because you'd have to talk about the temperature of the ice, okay? Because you can't bring in a third variable. So if you want to bring in ice, you got to talk about the temperature of the ice. Well, the temperature outside. Can we do something with that? Temperature outside, okay. So when it starts, it kind of looks like the temperature stays steady. Can you think of any time of the day that the temperature outside stays fairly steady? It doesn't really change a whole lot?
Midday.
Midday, okay. So we could say at noon. Right? Is that midday or not? What were you thinking of midday? Okay. At noon until about mid-afternoon?
Yeah.
Okay. At noon until about mid-afternoon, the temperature, well, I'm going to run out of room here. I better move to another spot, fix the line. The temperature, and we got to talk about where this temperature is at. Is it inside this school building here, outside, where? Is the temperature going to fluctuate inside the school building? No, it's probably got to be outside, right? Okay. At noon until about mid-afternoon, the temperature outside remained constant. Okay. Now we got that next section where it's going to decrease sharply. Remember, it's about 3 o'clock in the afternoon now. Well, no, we haven't described the decrease sharpliness. That's going to be our next region. So if at mid-afternoon it's going to decrease sharply, something has to happen with the weather. Snow. Okay. Maybe a cold front moves in? Yeah. Would that make it? Okay. So then a cold front.
Wait a minute, the temperature outside remains, you just put remains.
Oh, thank you very much. I forgot the word constant, didn't I? I start thinking I gotta move on. Okay. Then a cold front.
Abby Peterson to the junior high office, please.
Moved in. Do we have to say any more than that? Should somebody be able to, from our words, be able to tell that that's describing the falling part of the graph? Think we know something about cold fronts?
Yeah.
Yeah? Okay. Okay, now we're back to the, what's the next part of our graph? Constant again, okay, so what happened, what are we gonna say now? About what time of day is it now? Because remember, not much time went by here. So around early evening, supper time? What time?
4:30.
Late afternoon then?
Yeah.
Okay, later that afternoon. We're not writing really big, because you notice our story is getting kind of lengthy, isn't it? Later that afternoon, the temperature stayed the same until what? We probably better talk about what time of the day it is now. Until when?
6.
Okay, so maybe till early evening. Looks like there was about this much time going on between here, so until early evening. Interesting story, because what's going to happen now? It's early evening gonna increase pretty quickly. How often does the temperature increase quickly in the evening?
Not much.
Not very often.
Well, why not do it in the morning?
Well, we're not gonna change our story now we've done all this writing. We're gonna try to figure out how could we get the temperature to increase quickly in the evening? What would happen? The sun came up. So this is currently summertime and the sun stays up for a while.
Clouds are saying.
So what?
Clouds are
Okay, so clouds, the clouds moved away, the sun came out, and it warmed up quickly, or humidity, yeah. So tell me how we're gonna say this. Go ahead. Sure. Somebody tell me how we're gonna say this.
It will clear up very quickly.
Well, wait, you're not raising your hand because for some reason that's. Okay, go ahead, Blake. Okay, what?
Humidity factor.
Okay, so we can't just say humidity factor, we gotta describe that part of the graph. No, we can't, we gotta say something about, so, the temperature started to increase quickly because of humidity. There you go, I like that. The temperature started to increase quickly because of humidity. So in other words, you know, we got to make these real. It can't just be some sort of a, you know what? I'm just making up some random thing.
So on the homework page, right, it's stories.
Yeah, you do sometimes in your homework.
Shit.
Well, and you know, I was just sitting back here thinking, you guys are probably wondering, when are we gonna ever use this? You're gonna use it in physical science for probably 2 to 3 weeks. You're
Well,
gonna be
because that's a current.
doing graphs and having to pick out stories and stuff.
So, do you have any questions or any constructive comments to make to me about this? All right, then let's move on to the next one. I took up a whole lot of room for that one. Okay. There is the back side if you want to recreate a graph and move to the back, but hopefully you won't have to do that. Okay, graph B, we're going to call that one number 2. First decision we have to make is it a discrete or a continuous?
Discrete.
Discrete, yes, distinct points. Oh, I think this one's going to be a lot shorter story. But first thing we got to do again, remember we got to say, okay, we got the x-axis, and what's happening there? What's being represented on the x-axis?
Subway cars.
Subway cars, and specifically the number of subway cars, right? So we're going to say something about those subway cars because we can see that they're numbered 1, 2, 3, 4, 5, and 6. Okay, and then the y-axis is representing what?
Passengers.
Okay, what about the passengers? How cute they are? Number of them, 40, 80, 120, yeah. So number of passengers. So our story has to somehow include that, you know what, we got 6 subway cars, and we have up to 240 passengers with distinct points. What do you think we could say with this? Ollie, come up with something for me. And then at least engage this direction. Thanks. Anybody want to offer up something? Think you got this? Blake.
And the more subway cars that came in, the more passengers.
We could even be more specific than that. Okay.
As the day went on, there's
There's
no time.
no time involved in this one. Just subway cars and passengers.
In each subway car there are, okay,
goes with 40.
40 passengers.
Okay, so we have each subway car had, did we say holds 40
Yeah.
passengers? Okay, because we don't really know if they're full or not or anything, we just know that, yes, apparently you can put 40 passengers on a car. But are we sure, so did you follow it up? So when there's 2 subway cars, there's a total of how many passengers?
80.
80, okay, and it goes up at a steady pace like that, so we're pretty certain that each subway car holds 40 passengers. Each subway car holds 40 passengers.
And there are
And
6.
This
Yeah.
subway train, is that kind of what they're called? Am I right about that? This subway train, you know, there's cars on a train, right? This subway train has what? How many cars?
6.
6 cars.
Well, it only ends at 5 though. Like the 240 only goes up to 5.
There's
Okay, whatever.
6 points, I think there's 6 cars.
Yeah, but I only see like it's above 5.
If you
Oh, it kind of,
draw
I
lines,
see what you're saying, it just kind of lines up that way, it looks like, yeah. It's above 6, okay, so move it over. This subway train has 6 cars and can hold
240.
240 passengers. There we go. Much shorter story. Okay, questions about that one at all? Okay, let's try one more together here. I want to give you plenty of practice so you're not frustrated with this on the homework, on the worksheet, okay, when you have to do it. Okay, first of all, what kind of a graph do we have?
Continuous.
Continuous. That sounds like a longer story, doesn't it? Well, what also makes it longer is how many parts are there to the graph? 3. 1, 2, 3. Okay, so let's talk about this first one. In this first part, what's going on?
It increases.
Increases steadily. Okay. Okay, how about this part?
Constant.
Constant. Something's constant. And last but not least, how about the last part?
decreases.
Decreases steadily. Okay, so we're going to describe what's happening on the x-axis because that's going to be important in our story. What's happening on the y-axis because that's going to be important in our story. Because you got to be able to read that graph correctly. So x-axis, what happens there? As you go from left to right on it, what's happening? Time's going by. We don't know what it's measured in, we just know that time's going by. As you go from bottom up, or even it's sometimes in the graph when you're going back down, what's happening there? Distance from home. That from home is important. You cannot just say distance. That plays a really big role in our story, from home. We don't know what it's measured in. It could be blocks, it could be miles, we don't know that. Okay? So now our story has to start with, as time goes on, the distance from home has to increase steadily. Where are we starting out at? Are we starting out at home or are we starting out away from home? When the distance from home, we start out right here. What's
Starting from home.
so this is ordered pair what right there? What's the name of this point right here at the corner?
0.
The origin, 0, 0. Okay, so at the start, times 0, the x value, we are 0 blocks, miles, whatever it is from home. So where are we starting from? Home. Yeah, okay, so we're starting from home. So, somebody wanna be the character in our story today? Let's make it a person. Blake, you're gonna be the person? Okay. So Blake says, so Blake does what? Oh, Blake's, what's that? Blake,
Drives from home.
okay, drives from home
Onto interstate.
Okay, so remember now, in this, we have to talk about that. What should be increasing? Is speed? No, what does it say? Distance from home. So the amount, how far he is from home should be increasing, right? So when he drives to interstate, is he getting further away from home?
Yes.
Yeah? Okay. So Blake drives from home to interstate 94, you want it to be? Okay. Okay. So Blake drives from home to Interstate 94. Okay. That's the first part. What's happening now? It's constant. Huh.
And he stays at a constant speed of
Oh,
75.
there's no speed involved here.
He goes and is full.
He's not moving, is he? He's not covering any distance. So what is he doing?
Stops.
He stops what?
It's
Stops to get something to eat. Okay, so somewhere on Interstate 94, there's something to eat. Okay, so he stops to get something to eat. In other words, he's not putting any more miles on, right? But yet time is still going on. So time is going on, but the distance is not getting any more or any less, right? Well, okay, now we got that last one. Decreases steadily. What's decreasing steadily?
Distance from home.
Distance from home. Where does it eventually end up at?
Back to home.
Back at home.
And then he gets back on Interstate 94 and go back home.
He never left Interstate 94. He stopped there and he ate.
Then he goes back to the Interstate 94 and goes back home.
Turns around.
He turns around and goes home. Yeah. There you go. Okay, think you got this? Think you can do this on your own now? I think you can. I've been hearing some good stuff in here. Anybody have any questions or concerns?